Chromatography allows separation of compounds in a mixture by the differences in the polarity of those compounds in that mixture. Most typically, we would like to use column chromatography, which can be of varying sizes. Generally, they're a foot long, but they can be up to probably 30 feet long. We'd like to use column chromatography to separate large amounts of substance, but in order to know how to separate those substances, what solvent mixtures to separate those substances with, we'll test out the separation of the compounds in that mixture by using thin layer chromatography. We try to see which solvent mixtures give the best separations of compounds, and then we can use that same solvent mixture then on the large column chromatography. So first, let's talk about thin layer chromatography. Actually, let's talk about column chromatography. So typically you have a mixture of compounds produced in some chemical reaction, usually organic chemistry. Some mixture that has both A and B in it. But you want to get some pure B or some pure A. You can separate them by putting them over top of a layer of polar silica gel. So you've got this polar silica gel all throughout here. And here you have your mixture of A and B just over top of it. Now, if you add some solvent, which will run through this solution, that solvent will carry A and B through that silica gel, but those compounds will travel at different rates. You see that this silica layer is polar. Some polar compound A would travel fairly slowly through this gel. It sticks to the polar substrate, the silicon oxide layer. And the less polar compound B will travel fairly quickly through the column. It is not as attracted to the polar silica layer, so it runs with the solvent through the column and then is collected at the bottom. So you might see that compound B might move quickly and move off of the column first. You can collect that. And then column A moves more slowly. It only moves so far through the column as B is being collected. Later on, you can push that substance A out and collect that, ideally pure. So the central thing here is that the polar compounds, like polar A, don't move very much through the silica. They're attracted to the silica and less attracted to the solvent. And the less polar compounds, B here, move quickly through the silica because they're not very attracted to the silica layer and they're moving well with the solvent. We can decide which solvent mixture to use in this whole process using our thin layer chromatography, where we spot samples, ideally, of pure A and of pure B, and then the mixture from the chemical reaction. We try to see if we're able to get a large difference in travel distance between your compound A and your compound B. If you're able to get a large distance, then you should be able to do a nice extraction of A and B from each other on the column, using whatever this solvent mixture is. So again, polar A doesn't move up very much with the solvent. Polar B does move very much because it's less attracted to the silica layer. And so A doesn't move very much and B moves much more. The solvent moves up the thin layer chromatography plate by capillary action. It's drawn up those sides. So we can see here kind of a diagram of the solvent moving along the plate. So here's our plate. The solvent moves to the right, say. Now B not being very attracted to the plate, will sometimes stick to the plate, but then will hop off of the plate and into the solvent layer. It will spend a lot of time in the solvent layer and move therefore very quickly. But compound A, it hops up into the solvent, but then reattaches to the silica layer and kind of sticks there for a little while before getting carried into the solvent again and then sticking to the plate, carried into the solvent again, and sticking to the plate. Being that it's stuck to the plate so much, it doesn't travel as far as B in a given amount of time. Thanks for watching, guys.